DBS Talks. Okay, now in this class we are discussing the subject is utilization of electrical energy. Okay, so in this subject we have to discussing fourth unit. Okay, so in third unit you have to discussing the traction 2. Okay, so electric traction 2. So in fourth unit you have to discussing about the electrical traction 2. Okay, so before you are going to electrical traction 2, now you have to see the introduction about electric traction 2. Okay, so that is which topics we have to discuss it in this electric traction 2. See, first of all, the movement of trains and their energy consumption can be most conveniently studied by means of speed, distance and the speed time curves. Okay, so the movement of train, that means with how much speed the train will be moving on the track, and the energy consumption. Okay, for the movement of the train, okay, it consumes how much amount of energy can be most conveniently studied by means of speed, distance and speed time curves. Okay, by using the speed, distance curves as well as the speed time curves. Okay, the motion of any vehicle. Okay, the motion of any vehicle may be at constant speed. Okay, so the motion of any vehicle may be at constant speed, or it may consisting of periodic acceleration and retardation. Okay, so the speed time curves has significant importance in traction. Okay, so the motion, okay, so the motion of vehicle may be at constant speed. Okay, so that means the train will travels with same constant distance speed, or maybe it consisting of periodic acceleration and retardation. That means sometimes this maybe speed will be increases, and that is nothing but acceleration, and sometimes the speed will be maybe decreases, that is nothing but retardation. The speed time curves have significant importance in traction. Okay, so here the speed time curves have the more importance in traction. Okay, so if the frictional resistance to the motion is known value, the energy required for the motion of the vehicle can be determined from it. Okay, so that means if suppose the frictional resistance, okay, the frictional resistance to the motion, if suppose for the motion how much amount of friction resistance will be utilized is known, that is known, so at that time the energy, okay, so the energy required for the motion of the vehicle can be determined from it. Okay, moreover this curve gives the speed at various time instants after the start of run directly. Okay, so the speed time curve gives the speed at various time instants, okay, at different times after the start of run directly. Okay, okay, so what are the types of services? Okay, so types of services may see here. There are mainly three types of passenger services by which the type of traction has to be selected. Okay, so here mainly, so there are mainly three types of passenger services. We are using the three types of passenger services. Those are mainline services, urban or city services, suburban services. Okay, mainline services is nothing but those trains will travel to long distances. See here in next slide we have to discuss. See, first one is what? Mainline services. So what are the mainline services means? See, in the mainline service the distance between the two stops is usually more than 10 kilometers. So whenever in mainline services the distance, okay, so the distance between the two stops, okay, the distance between the two stops is usually more than 10 kilometers. Okay, so that services are called as mainline services. Okay, high balancing speed should be required. Okay, for mainline services it requires the high speeds. Okay, high balancing speeds. Acceleration and retardation are not so important. So here acceleration and retardation will not important. Okay, so next one is what? Urban services. Urban. So in the urban services also called as city services. In urban services, the distance between the stops is very less. Okay, for example, metro trains. Okay, so that is, and it is less than 1 kilometer. Okay, so and the distance between the stops is less than 1 kilometers, and it requires high average speed for frequent starting and stopping. Okay, so and it requires the speed to start this suddenly to start this train or stopping of the train. It requires the high speed. Okay, next one is what suburban services. In the suburban services, the distance between the two stations is between 1 and 8 kilometers. Okay, in suburban services, okay, the distance between the two stations is in between 1 to 8 kilometers. This service requires rapid acceleration and retardation. Okay, and this service requires rapid acceleration and retardation as frequent starting and stopping is required. Okay, so that means it is having the various accelerations and various retardations. So and frequent sudden stoppings and starting and stoppings will be required. These are the so these are very important. What are the types of services? The passenger services. The trains are mainly classified into three services. What are those? Mainline services, urban services, suburban services. If the distance between the two stops is usually more than 10 kilometers, okay, that is called as mainline services. Urban services is nothing but if the in urban services the distance between the two stops is less than 1 kilometer. Okay, so that is nothing but the urban services. Suburban services means in suburban services the distance between the two stations is between 1 and 8 kilometers. Those are called as suburban services. Okay, so now here we have to see the speed time and speed distance curves for different services. Okay, speed time, okay, and speed distance curves for different services. See here the curve that shows the instantaneous speed of train in kilometer per hour along the orbit and time in seconds. So whenever you have to draw a curve between okay speed of the train, okay, and that speed will be represented in kilometer per hour and time in seconds. And we have to take the time in seconds along the bus visa is known as the speed time curve. Okay, similarly the curve shows the distance between the stations in kilometers along the net, okay, and time in seconds. So whenever you have to draw in between distance and speed, the distance and time, okay, that is nothing but speed distance curve. Here speed and time, okay, speed time curves. Distance and time, that is nothing but speed distance curve. Okay, the area, so whenever you have to draw a curve, the area under the speed time curve gives the distance traveled during given time interval and slope at any point on the curve towards gives the, see here, whenever you have to draw a curve, that is the speed time curve or speed distance curve, so the area under the curve will be gives the area speed time gives the distance, how much distance the train will be traveling is find out by using that area. Okay, see the speed time curve for the mainline services are mainline service. So in next slide you have to see the speed time curve for the mainline services. Okay, so see here the speed time curve for the mainline services mainly consisting of these time periods. What are those? Constant acceleration period, acceleration on speed curve, free running period, coasting period, braking period. Okay, so the speed time curve for mainline services consisting of following time periods. What are those? Constant accelerating period, acceleration on speed curve, free running period, coasting period, braking period. See, this is the here generally you have to see the speed time curve for the mainline services. See, this is the speed time curve. So on y-axis, okay, you have to take the speed in kilometer per hour. On x-axis, you have to take the time in seconds. So this is the speed time curve. Okay, so first whenever for example you have to take the mainline services. So first whenever the train will be starting at slow speed. Suddenly the speed, so that means first starting the train will start with some constant speed up to some particular point. So this period is called as constant acceleration. So whenever it slowly will be starts at a particular point, the speed of the train curve increases. So whenever it travels with high speed at a certain particular point, again it will maintain it. So whenever the speed will be rises, okay, whenever the speed that train speed will be increases, after that in some particular period time period, some up to some particular period time period, the train will moves along with them some that high speed, same speed, that is nothing but the free running period. After that, so whenever that train will be moves along that high speed, after that whenever it reaches to the station. So what happened? The train speed will be that means the train will be stopped. Okay, the train to be stopped compulsory. So that's why again the speed of the train will be increases slowly. That period will be called as coasting. And finally again the speed is very much less, and finally the train will be stopping. That period will be called as braking. That means finally we have to brake. Okay, so that period is called braking period. Okay, so these are the five periods, five time periods occurred from the speed time curves. What are those? Constant acceleration period, acceleration on speed curve, free running period, coasting period, braking period. The area under this curve, this total curve will give us the how much distance the train will be traveled. Okay, that is find out by using the area under this curve. So that means in between 0 to T1 period, okay, that period is called as constant acceleration period. In between T1 to T2, that period is called acceleration on speed curve. In between points B and C, that period is called free running period. In between points C and T, that period will be called as coasting period. And in between points D and E, that period will be called as braking. Okay. So already I have explained. Okay, what is see here? What is constant acceleration? During this period, the traction motor acceleration from rest. Okay, the curve OA represents the constant acceleration period. Okay, that means this is curve 0 OA. Okay, so OA will represents the constant acceleration period. During the instant 0 to T1, the current is maintained approximately constant, and voltage across the motor gradually increases by cutting the starting resistance, slowly moving from one notch to other. So whenever, so what is the constant acceleration period made? Whenever the train will be start from rest position. Okay, that period is nothing but the constant acceleration. In the speed time curve, here the curve OA. Okay, here the curve OA will represent the constant acceleration period. Okay, so during the instant 0 to T1, the current is maintained constant, but the voltage is gradually increased. Okay, the current slowly taken up by the motor, and the tractive effort are practically constant, and therefore acceleration remains constant during this period. So here the current is almost constant, so that's why in this period, okay, the acceleration is also remains constant. Hence this period is called as notch-up acceleration period or rheostatic acceleration period. Okay, this constant accelerating period is also called as notch-up accelerating period or rheostatic accelerating period. Okay, typical value of acceleration lies between 0.5 and 1 kilometer per hour. Okay, so actually the constant acceleration period, the typical value of the acceleration lies in between the 0.5 and 1 kilometer per hour. Acceleration is denoted with the symbol alpha. Here the acceleration will be denoted with symbol alpha. Okay, this is the constant acceleration. Next, which period? Acceleration on speed curve. Okay, so acceleration on speed curve. During the running period T1 to T2. Okay, the period T1 to T2 will represent the acceleration on speed curve. Okay, so the voltage across the motor remains constant and the current starts decreasing. This is because so at that time the current will start decreasing. Okay, so at the time whenever current will be decreases, so at the time speed will be increases. Okay, so at the so whenever the speed will be increases, that means the acceleration. Okay, so acceleration will decreases with increase in the speed. Finally, the acceleration reaches to 0 for the certain speed. So at that time, the acceleration reaches to 0, and it will the train will move with a certain speed. Okay, so this decreasing known as the acceleration period is shown by the curve AB. Okay, so that is nothing but the acceleration on speed curve. Okay, so next one is what? Free running or constant speed period. The train runs freely during the period T2 to T3. In previous speed time curve, I will explain free running period. So in this free running period, the train travels along with the constant speed. Okay, so here the train runs freely during the period T2 to T3 at the speed attained by the train at that instant T2. During this speed, the motor draws a constant power from the supply lines. This period is shown by the curve BC. Okay, so this is the free running period. Next one is what? Coasting period. Okay, so in a speed time curve, the coasting period is from T3 to T4. That is from C to D. Okay. So at the instant T3, power supply to the traction, the motor will be cut off and the speed falls on the account friction, windage resistance. So during this period, the train runs due to the momentum attained at that particular, the rate of the decrease the speed during this coasting period. Okay, so during the coasting period, that speed will be decreases. This is also known as the coasting retardation. So the decreasing in the speed will be called as retardation. Okay, so usually it is denoted by the symbol beta C. Okay, retardation will be denoted with beta. Next one, final period. Okay, so final period is what? Braking period. Okay, so braking period is from T4 to T5. Okay, here the braking period is from T4 to T5. That is from D to E. That is from D to E. At the end of the coasting period at T4, brakes are applied. Okay, brakes are applied to bring train to the rest. So finally, whenever the train will reaches the station, so at the time to stop the train, you have to compulsory brakes are applied. So at T4 interval, you have to apply the brakes. During this period, the speed of the train decreases rapidly and finally reduces to 0. So at that instant, okay, so at that instant, the speed of the train decreases rapidly and finally reduces to 0. In mainline services, the free running period will be more. So you have to mainline services, urban services, suburban services. Compared to these all services, in mainline services, the free running period, okay, the free running period will be more. Okay, so the starting and braking periods are very negligible. So in the mainline services, starting and braking periods are negligible since the distance between the stops for the mainline services is more than 10 kilometers. Because of the more than 10 kilometers, okay, braking and starting are negligible. Okay, speed time curve for the suburban services. See, this is the speed time curve for suburban services. Then in speed time and suburban services, see here you have to only acceleration. Okay, coasting, braking. Okay, so in previous diagram is for mainline services. This is only for the suburban services. So in suburban services, starting period and mainline period are negligible. Okay, so that means see here the speed time curve for the urban services consisting of okay, in suburban services they are acceleration, coasting, retardation. Okay, for this service there is no free running period. So here there is no free running period. The coasting period is comparatively longer distance since the distance between the stops is more. Okay, here the coasting, okay, the coasting period is high. Why? Because here the distance between the stops is more. Okay. Braking and retardation period. Braking and retardation period is comparatively small. It requires relatively high values of acceleration and retardation. Okay, so for the suburban services, braking and retardation period is also small, as well as it requires the higher values of acceleration and retardation. Okay, so typical acceleration and retardation values are lying between 1.5 and 4 km per hour and 3 and 4 kilometer per hour. So acceleration values are lies in between 1.5 to 4 kilometer per hour. You suppose retardation values are lies in between 3 and 4 kilometer per hour respectively. Okay. See here speed time curve for urban city services. See, this is for urban services. Okay, so this is the urban services speed time curve. Here also see this is also same as suburban services. In this service, there is no free running period. Here also there is no free running period. The distance between the stops is less than 1 kilometer. So hence relatively short coasting and longer braking period is required. So that's why, so here the distance between the stops is very less, that is about 1 kilometer. Okay, so that's why here the short coasting and long braking period is required. The relative values of acceleration and retardation are high to achieve the moderately high average between the stop. So here the values of acceleration and retardation is also high. Here small coasting period is included to save the energy consumption. Okay, so here coasting period is also included small. Why? Because to save the energy consumption. Okay, the acceleration for the urban service lies between 1.6 and 4 km per hour. Okay, here the acceleration. Okay, so the acceleration for urban services value lies between 1.6 and 4 km per hour. The coasting retardation and the coasting retardation is about 0.15 km per hour, and the braking retardation is lying between 3 and 5 km per hour. Okay, similarly the braking retardation. The braking retardation is also lies in between 3 and 5 km per hour. Okay, these are the speed time curves for the mainline services, urban services and suburban services. So relating to this traction, here you have to some definitions. We have to discuss these definitions. Crest speed. Okay, what is the meaning of crest speed? By is the maximum speed attained by the train during the run is known as crest speed. Okay, so whenever the train will be in running position, okay, so whenever the train will be in running position, so at that time the maximum speed attained by the train, okay, so at that time the maximum speed attained by the train is called as crest speed, and it is denoted with Vm. Okay, and crest speed is denoted with Vm. And next one is what? Average speed. Average speed is nothing but it is the mean of the speed attained by the train from start to stop. So average, whenever at the starting it having some speed, and start to stop it having a different speed. So whenever you have to take the mean average of the speed, that is called as average speed. It is defined as, so in definition point of view, it is defined as the ratio of distance covered by the train between two stops. Okay, so what is the, so two stops means from starting station, ending station. Okay, so that means it is defined as the ratio of the distance covered by the train between two stops to the total time of run. Okay, so what is the time period will be taken for the run? Okay, see here, it is denoted by VA. Okay, average speed is denoted by VA. So average speed equal to distance between stop by actual time of run. That is VA equal to D by T. Okay, so this is the formula for average speed. So VA, where VA is the speed of the train in kilometer per hour. So here V is the speed of the train in kilometer per hour, D is distance between the stops in kilometers, and T is the actual time of run in hours. Okay. Next one is what? Scheduled speed. Okay, first one is crest speed, second one is average speed, and next one is scheduled speed. Okay, scheduled speed is nothing but the ratio of distance covered between the two stops to the total time of the run, including time for stop is known as scheduled speed. Okay, so that means what is the scheduled speed? Scheduled speed is defined as the ratio of distance between the two stops. Okay, two stops to the total time of run. Okay, the time period will be taken for the including the stopping. Okay, how much time period the train will be stopped? That is nothing but the scheduled speed. It is denoted with the symbol Vs. Okay, here the scheduled speed will be denoted with the symbol Vs, where Ts is the scheduled time in hours. Ts is nothing but scheduled speed in hours. Scheduled time, it is the sum of the time required for the actual run. So that is T run plus T stop. Okay, so that is nothing but the scheduled speed. Okay, that means scheduled speed equal to distance between the stops by T run plus T stop. Okay, so that is nothing but the scheduled speed. Next one is what? Factors. Some factors will affecting the train of the speed. Okay, so what are the main factors that will affect the scheduled speed of a train? Here we have to see the crest speed, the duration of stops, the distance between the stops, acceleration, braking retardation. Okay, see here. So what are the factors affecting the train of the speed? First one is crest speed, the duration of stops, okay, the distance between the stops, acceleration, braking retardation. These are the 5 factors will affect this scheduled speed of the train. First one, here you have to see the crest speed. Okay, the crest, in which way the crest speed will affect the speed of the train. Now here you have to discuss. It is the maximum speed of the train which affects the schedule speed. Okay, whenever the crest speed will be crest speed is nothing but maximum speed will attained by the train. That is nothing but the crest speed. It is the maximum speed of the train which affects the schedule speed as per fixed acceleration, retardation, and constants between the stops. So at that time, whenever the maximum, so at that time it affects the schedule speed. So what is the if the crest speed increases, the actual running time of the train will be decreases. So whenever the crest speed will be increases, so at the time actual time period. So what is the time period you have to setting for the running the train, that will be decreases. For the low crest speed, the train is running so high crest speed, train will increases its schedule speed. Okay, for the high. So whenever high crest speed, that train scheduled time will be increases. So duration of the stops is more. So at the time the duration of the stops is also more. So then the running time of the train will be less. So at that time running time will be less, so that it leads to the low schedule speed. Whenever the running time, and so whenever the schedule speed will be affected, at that time the duration between the stops is more. So at that time the running time of the train will be less, so that it leads to the low schedule speed. Okay, for this high schedule speed, the duration of the stops must be low. Okay, here to get the high schedule speed, this duration of the stops must be low. Okay, so distance between the stops, if the distance between the stops is more, then the running time of the train is running time of the train is less. Okay, so hence the schedule speed of the train will be more. Okay, compulsory you have to maintain the schedule speed of the train is more. Next one is what? Acceleration. Okay, so see here, distance between the stops, duration of the stops, we have to discuss. Okay, so these in crest speed, so what are the factors affecting this? The duration of the stops, distance between the stops. Next we have to see how will affect the acceleration and braking retardation for the schedule speed. See here, so next you have to see acceleration. If you have to take the acceleration into account, if the acceleration of the train increases, then the running time of the train decreases. Okay, so whenever if the acceleration of the train increases, so at that time, okay, running time of the train decreases, provided the distance between the stops, okay, and the crest speed is maintained as constant. Okay, so whenever acceleration will be increases, running time of the train will be decreases. So at that time crest speed will be maintained constant. Thus in increases acceleration will increase the schedule speed. Okay, so at that so whenever you have to maintain the crest speed will be constant, thus increase the acceleration will increases the schedule speed of the train. Okay, that is nothing but the acceleration. Next one is what? Braking retardation. Braking retardation is nothing but high braking retardation leads to the reduction of the running time of the train. So whenever you have to apply the high braking retardation, so at that time it will cause the reduction in running time. Okay, running time of the train. This will cause high schedule speed provided the distance between the stops is small. Okay, so at that time it will cause the high schedule speed and the distance between the stops will be also small. So these are the factors affecting the schedule speed. Okay, so now in this class we are discussing the interaction. So what are the services for the passengers? What are those? Mainline services, urban services, suburban services. Okay, how you can describe these services by using the speed time curves. Okay, so we have to discuss in that speed time curves. Later you have to introduce some simplified time curves. Okay, simplified time curves for the suburban services and mainline services. Those are discussed in later class. Okay, thank you.